Hi, welcome to another video. Today we'll be solving the question of copying linked list with random pointers. So let's have a look at the problem. So we are given this singly linked list starting at node 7. Here the head is at node 7 and it goes all the way till node 4. And normally in linked list problems, so for a linked list node, we are usually only given the value and the next pointer. So here the next pointers are such that 7.next points to 13, 13.next is at node 11, and along with value and next pointers, we are also given random pointers for a node. So what could happen with random pointers is the random pointer of node 7 can point to any node in the linked list, or it can be null as well, or it can point to itself. So for example, 7.random, it points to node 10, and nodes 13 random pointer is null, and 11.random is 13, and random pointer of node 10 is pointing to node 13 again, and random pointer of node 1 points to itself, and random pointer of node 4 is null. So here we have to copy this linked list into a new linked list. So we have to create a deep copy. So we have to create brand new nodes using new operator, and we have to copy the next pointers and also the random pointers. So let's have a look at a simple brute force approach that we can use to solve this problem. So let's assume we only know how to traverse a linked list. So initially we are given the head reference pointing at node 7. So what we can do is we can iterate over the linked list, and as we are iterating, we can create our deep copies, and this will copy the next pointers. And our first step would be done of copying the next pointers and also assigning the node values. And the final step is assigning random pointers correctly. So to assign random pointers correctly, what we can do is we have to traverse over the original linked list. And as we are traversing over the original linked list, we have to perform two steps. We have to find the index of the random node and then find the random node by again traversing our new linked list. So to find the index of the random node, we traverse our original linked list, and once we have the index of the random node, we traverse in our new linked list to find the random node in the new linked list. So initially, if we are starting at node 7, so 7.random, it's pointing at node 10. It points at node 10, so we call it random. And we have to find the index of this node 10. So we can get this node 10 in constant time by just referencing 7.random, and we get this node. And now we have to get the index. So to get this index, we need to iterate from the head of the linked list and count the number of steps. So it's going to be 1, 2, and 3 steps to reach the node 10. And now when we are at our new linked list, we have to iterate 3 steps again, and we reach node 10 here. And now we can assign 7.random to this node 10, and this way we can assign the random node in our new linked list. And now we can move on to the next node. So now if we reach node 13 here, so 13.random is null. So if it is null, then we don't need to do anything, and we move on to the next node. So now when we have node 11 now, so 11.random is node 13. So now we have to find this node 13's index in our original linked list. So again, we have to start from the head of the linked list. So the reason we have to start from the head of the linked list is in a linked list, we can only move forward. We cannot move backwards as we are only given next references, and so this is a singly linked list, so that's why we can only move forward. So we start from node 7 again, and this is only one step, and we now come to our original linked list. So here we find our node 13, and now we can assign the random pointer of node 11 in our new linked list. So as we are iterating over our original linked list, we are also iterating over our new linked list. So as we are iterating, we are performing two steps, and so this is going to lead to time complexity of O of n square, and we are not using any extra space other than creating new nodes, so we don't count creating new nodes as extra space, so it's just going to be O of 1 space. So now we have to think about how we can optimize our time complexity. So usually when we have to optimize time complexity, we make use of extra space. So let's have a look at how we can use extra space to improve our time complexity. In our O of n square approach, so the thing which is leading to O of n square is searching for the random node in our new linked list. So here we are searching for the random node in new linked list. So this is a search operation. So the data structure which helps to optimize search operations is hash map. So we can utilize a hash map based approach to solve this question. So as we are copying the next pointers from original linked list to create new linked list, what we can do is, as we are iterating over the original linked list, we can create a mapping of the node from original linked list to new linked list. So this node 7 maps to node 7 in our new linked list. This node 13 maps to new node in the new linked list, and so on. So this way, when we are done copying the next pointers in our next O of n iteration, what we can do is we can copy the random pointers correctly. So when we have to copy the random pointer of this node 7, so let's say node 7 points to node 10, 7.random points to node 10. So here we can quickly get the random node in our new linked list by just doing a get operation on our hash map. So when we do 7.random, we get this node 10, and then we do map.get and then pass on this node and we get this node 10, and then we can assign 7.random to our node 10 in our new linked list, and so on. And if the random node is null, we simply don't do anything, and this way we can simply copy our random pointers correctly and we will be done. So this will make more sense as we write the code for this approach. Before writing code, let's also have a look at O of n time complexity and using constant space. Now the next question we can ask ourselves is, can we do better? Can we do better than O of n time and O of n space? So the answer is yes, we can do better in terms of space. We can do this question in O of n time and O of 1 space. So let's have a look at that approach using constant space and O of n time. So that approach will involve modifying our original linked list. So let's have a look at that. So here we are given our original linked list and we are using this current variable to iterate over the original linked list, and as we are iterating, we are creating our nodes of the new linked list, and initially we assign it new head and using current node to iterate over the new linked list. So here when we created this node 7, what we are going to do is we are going to update the next pointers in our original linked list, and we are going to assign this 7.next to this new node 7 and the next pointer of our new node to the next node in our original linked list. And now we move forward in our original linked list. Now we move to node 13. So now we create node 13 in our new linked list and we update 13.next to point to this node 13, and the node 13 in our new linked list, the next pointer is going to point to node 11, and so on. So basically, as we are creating the nodes in our new linked list, we are merging it in the original linked list. So here node 7 comes in between node 7 and 13, and node 13 in our new linked list is going to come in between node 13 and 11. And similarly, as we move on, we are going to have node 11, then node 10, node 1, node 4, and this pointer is going to come here. This one points to node 10, then 10.next points to node 10 in our new linked list, and 10.next in our new linked list points to node 1 in our original linked list, and so on. and this, and finally 4.next in our final linked list is going to be null. So here now we have modified our original linked list. So we have modified the next pointers and the random pointers remain as it is. So now if we think about copying random pointers, what we can see is 7.random is node 10, and if we want to get the random pointer in our new linked list here, so we can see that 10.next points to the random node for new linked list. So the random node in our original linked list, that node's next pointer points to the random node in our new linked list. So this way we can get the random node in O of one time. And this way we can simply copy the random pointers. We can assign 7.next, 7.random to this node 10 and so on. And finally, when we are done, we have to restore the next pointers in both the linked lists. Restore next pointers in both of the linked lists. What we can do is we can set current.next equal to current node.next. So here we have current.next. So we have to update this pointer to point to current node.next, which is node 13. So we removed this pointer and updated it to node 13. And now we have to update the next pointer of current node. So current node.next here, it should point to current.next.next only if current.next is not null. So we have to add a null check for current.next. If it is not null, then we can simply assign it to current.next.next. This way we can update the next pointers and restore them to their original values. And at the end, we can simply return new head, and this will return the final cloned linked list. So now let's have a look at the code implementation for both the approaches. For our code implementation, we have to implement this copy random list function and return the head of our cloned linked list. So first we're going to write the hash map approach, and then we'll cover the constant space approach. So let me start by writing our hash map. So I have to create node to node mapping, and then new hash map. And I have to use a current variable to iterate over original linked list. And for our cloned linked list, since we have no information about our cloned linked list, so using a dummy node for our cloned linked list, that would be helpful so that we don't have to deal with null pointer checks. Node -1, and can create current node to iterate over our cloned linked list. Dummy. And now we have to iterate over our original linked list. Current node equal to null. And as we are iterating, we can create a node of our cloned linked list. We can do is new node current.val, and then we can assign current node.next equal to new node, and then we can create a mapping of current and new node. Once we are done with this, we can move our current equal to current.next and current node equal to current node.next. So after we are done with this while loop, we have the next pointers set correctly and the map will be populated, and we have the mappings of the nodes from our original linked list to our new linked list. And finally, we have to assign random pointers correctly. So to assign random pointers correctly, we have to do one more iteration. So what I can do is I can reset my current equal to head and current node equal to dummy. Then I can have a while loop. So here in my while loop, I can only check either current or current node. I don't need to check both of them because we know that both the linked lists are going to be of equal lengths. So once I have done this, I need to get the random node. So what I can do is current.random is not equal to null. Then I can get the mapping current.random, or if it is null, then I can simply assign it null. So this will give me the random node in my cloned linked list. and then I can assign current node dot random equal to random, and then I can move my current equal to current dot next and current node equal to current node dot next, and at the end I can return dummy dot next, and this will be the head of my cloned linked list. So let's try to run it, and it says compile error line 38. This should be random. Let's try to run it again. Okay, we did some mistake, so let's try to identify. So let's try to debug this again and go through this again. So I created this map, then I have my current, then dummy, then current node again, then new node, current dot val, current node dot next equal to new node. Then I created the mapping, then I have to assign my random pointers head, and this will be, so this is going to be dummy dot next. We try to run it again. Yeah, and that works, which is good. So here I just had to update it to dummy dot next. So dummy dot next is the head of my clone and not dummy, so that's why it was throwing an error. So let's try to submit it, and yeah, that works, which is good. And now let's move on to our constant space and O of n time approach. As discussed from our algorithm walkthrough, we are going to merge the new nodes in our original linked list. So let's see how we can do that. So initially what we can start with is we create node current equal to head. So this will iterate over my original linked list, and as I am iterating, what I can do is node new node current dot val, and before I have to store the next reference, be current dot next. Now I have to update my current dot next equal to new node and new node dot next as next, and move my current equal to next. So this way I will merge the new nodes in between the two nodes of my original linked list. So now I have to assign random pointers correctly. Before assigning random pointers, so let me save the head of my cloned linked list. So I can create new head here, and what it's going to be, it's going to be head dot next. So this head dot next is going to throw null pointer exception if head is going to be null. So what I can do is I can check if head is null, simply return head. And now I have saved my new head, and I can reassign current equal to head. To assign my random pointers correctly, I'll iterate over original linked list again, and what I can do is I can create current node equal to current dot next. So this current node is the node in my cloned linked list, and now I can find the random node. So random is going to be current dot random dot next, and if current dot random is not equal to null, only then we assign it to current dot random dot next, else it's going to be null. And now we can assign current node dot random equal to random, and next we can move our current equal to current node dot next. Either we can do current node dot next, or we can do current dot next dot next. And once we have done this, we need to restore the next pointers in both the linked lists. So to restore both the linked lists, what I can do is I can again reinitialize current equal to head, and I have to iterate over my linked list again. Then I can again have current node equal to current dot next, and I have to update my current dot next equal to current node dot next, and current node dot next is going to be current dot next dot next. Only when current dot next is not equal to null, else it's going to be null. And it is guaranteed that my current node is not going to be null, because for every current node we have every current we have a current node, and that is why current node dot next is not going to throw null pointer exceptions, and basically my current node is never going to be null. So once I have assigned both the next pointers, now I can move my current equal to, so this is going to be, so I set my current dot next. Yeah, so I'm going to update my current equal to current dot next, and at the end I have to return the new head. So let's recheck and just verify if we did everything correctly. So initially we create our new node, we set current dot next equal to new node, and then assign new node. Then we set current equal to next, and when setting our random pointers, we have current node, and then we get the random pointer, so current dot random dot next, and then I assign my current node dot random equal to random, and then I set my current equal to current node dot next. So that looks good. And finally, when restoring, so I have my current here, my current node here, so current node dot next is going to be current node dot next here, and the node dot next here is going to be current dot next, and current equal to current dot next. So I think that looks good, and let's try to run it. And yeah, that works. And let's try to submit, and yeah, that works as well. So I hope both the approaches made sense, and if you have any doubts, let me know in the comments. And thank you so much for watching, and I'll see you in the next video.